Okay, so we're going to look at evaluating a definite integral now using substitution. And before we do that, I want to compare an indefinite to a definite integral. So here I have the indefinite integral that looks similar to this definite integral, and the indefinite integral does not have limits of integration, while the definite integral does. And the difference here is the indefinite integral just means the antiderivative of the function. And we know this through the fundamental theorem of calculus. Now when I say antiderivative, I mean the general antiderivative. This function has lots of antiderivatives, and I mean the generic one. Okay? The answer to an indefinite integral is a function with the variable z in this case. Okay? Now over here, to evaluate a definite integral, you still invoke the fundamental theorem of calculus and you use the antiderivative, but this meaning of this is not an antiderivative. The meaning of this is the area under the function z squared over z cubed plus 1 from z equals 0 to z equals 2. Okay, and we can define that using a limit of Riemann sum. Now the answer to a definite integral is a number. So over here, when you get your answer, you should expect z's in your answer typically, because this is a function of z. Over here, you just get a number. So when we use substitution to evaluate this integral, it's very important that we end up back with z. However, if we do substitution with this integral, we're not concerned with our answer being in terms of z, we just need a number. So as we see when we do this example in a minute, we're not actually concerned with, once we make our substitution, we're not necessarily concerned with going back to z. Okay, so let's actually evaluate this definite integral now. So we treat this integral much like the indefinite integral to begin with, and substitution is a good candidate because the derivative of z cubed is 3z squared. Okay, and that could give us the z squared up here. So if we actually make the substitution now, we'll let u equal the z cubed plus 1, and then after we take the derivative, we'll see that du equals 3z squared dz. And so this integral is basically going to become, forget about the limits of integration for a moment, it's going to be 1 over u, because 1 over z cubed plus 1 is 1 over u. And then we need now to take care of our z squared and our dz, and so to do that we come back over here and solve for z squared dz and see that that equals 1/3 du. So we build those back into our integral here, where the 1/3 we could put in the front since it's a constant. We have this. And for now, so we've got this just like it's an indefinite integral, but now we need to put on some limits of integration, and we have to be a little careful now. So the idea is, in the original integral, these are, the limits of integration are in terms of z. Z equals 0 to z equals 2, and we know that because the integral is with respect to z. Now, down here, the integral is with respect to u, so these should be u values. Okay, so we've got two options for actually evaluating this integral now. We'll do this option first, where we write the limits of integration, in terms of u. Okay, so right now our limits of integration are z equals 0 and z equals 2. So what does that tell us about u? Well, luckily, we have a relationship here in this equation, u equals z cubed plus 1. It tells us that if z is 0, u is 0 cubed plus 1. So when z is 0, u is 1. And if z is 2, u is 2 cubed plus 1, which is 9. So now we can rewrite the integral as 1/3 times the integral from u equals 1 to u equals 9 of 1 over u du. And now we can proceed to evaluate this integral. Okay, so when we do that, we end up with 1/3, assuming you've got some knowledge of antiderivatives and things, you get 1/3 times the natural log of absolute value of u plus c, and we need to evaluate that integral from u equals 1 to u equals 9. So we get 1/3 times the natural log of the absolute value of 9, which is 9, plus c, minus the same thing when we plug in the 1, 1/3 times the natural log of the absolute value of 1, which is just 1, then we get plus c, and we simplify that now. The natural log of 1 is 0, the c's cancel when we subtract, so the answer is 1/3 times the natural log of 9, and that's a number, and that number represents the area under this curve from z equals 0 to z equals 2. So this is option 1, where you rewrite your limits of integration in terms of u. Another option is to ignore the limits of integration until we get back to z. So notice in this technique, we started with z, we went through u to get the area. We never went back to z like we did with an indefinite integral. So we can use that technique where we go back to z as well, like we did on the indefinite integral. And this is how you would do it. You would leave your limits of integration as being unknown when you're talking about the variable being u. So we'd have 1/3 natural log of absolute value of u when you take the antiderivative, plus c, evaluated at unknown limits because the variable is still u. However, now we can plug in z cubed plus 1 for u, and we rewrite this as 1/3 natural log of absolute value of z cubed plus 1 plus c. Now we could say that's evaluated from z equals 0 to z equals 4, because the variable is z, and we know that z varies from 0, sorry, not to 4, but 2. And then we proceed just like we did before. We're going to have what we get when we plug in the 2 minus what we get when we plug in the 0. So we get 1/3 natural log of, plug in the 2 for z, and you get 8 plus 1 is 9. The absolute value of 9 is 9, so we get natural log of 9 plus c. And then same thing over here, plug in 0 for z, and we get the natural log of 1 plus c. Simplify it just like we did. This is 0, the c's cancel, and we get the exact same answer, 1/3 times the natural log of 9, and that's the area under this curve from z equals 0 to z equals 2. So whichever technique you choose, see the differences between them. Just be really careful. If you don't know your limits of integration, don't put them in there. This is respect to variable u. So unless you're going to go through the trouble of calculating them in terms of u, like we did here, then just leave them unknown, rewrite it in terms of z, and then use the given limits of integration, 0 and 2 in this case.